Welcome to the satellite communication course. In last lecture, we have seen that antenna and a feed system. What are the various types of antennas that are used in a satellite? So there are a prime focus antenna. Then we can say Cassegrain antenna, dual reflector antenna, multiple beam antenna. Now this one is about a prime focus antenna that we have seen in the last lecture. That is about a at a focal point, a horn antenna is placed, and this one is a reflector is present. We can say that primary antenna and this one is a secondary antenna. When we use as a transmitter, signal coming out from this horn that will that will be reach at this reflector. So then reflector is a metallic object. So that's why by property of a microwave signal, so it will reflect that a microwave signal. That's why the signal get reflected. It is propagating in a space there. When we use as a receiver, so incoming signal from this space bombarded on this reflector here, then it will be reflected from this reflector and then at one particular focal point. So all the incoming rays are collected there. That collection takes place in a horn itself. So that is about a primary focus antenna that we have seen. And then we have seen that a Cassegrain antenna, instead of at a focal point, horn antenna is to be placed. Instead of that, below that parabolic reflector, that horn antenna is to be used. So this one is about a feed horn. And here are the two reflectors are used. One is the main reflector, this is a parabolic reflector, and at the focal point there is a subreflector. Now, signal coming out from this horn antenna, it will bombarded on this subreflector and then reflected from this, raised to this main reflector, then again reflected from this, and this way we can use as a transmitting antenna. So now here, if you see that in the both the cases, that antenna is present on the axis, main axis of a parabolic reflector. So another type of an antenna that we can say that a offset antenna. So now in the case of a offset antenna, this is about a axis, on that axis that antenna is present. So another antenna is about a offset antenna. Now if you see that this antenna is at a present at a focus main axis there, and because of that main axis, what happened? So there is some small spurious signal will come out from this particular region because this parabolic reflector will not match with this particular subreflector. Even if we have a horn, some signal can go away from this, so that is a spurious signal we say, and that spurious signal is nothing but the spillover for this horn antenna. Sorry, that reflector antenna. So now that to avoid the spillover there, or another case is about what this structure is act as a blockage for the incoming rays as well as for the transmitting rays. Because horn antenna is placed, so whichever the incoming rays come from this particular side, so that will be blocked by this horn antenna. So that's why it is called as a blockage antenna. So that is the block here. So now in that case, we can consider another method for removing that particular blockage, and that blockage is to be reduced by using the off axis antenna or opposite antenna. So here in this case of a Cassegrain feed, so instead of a horn antenna, in a Cassegrain feed, subreflector is used. But even if that subreflector is again, it act as a blockade. blocking the waves here. That is about the waves incoming from this particular region that will be act as a blockage here. So to reduce the blockage of an antenna, so we need to consider that a offset antenna. If there is a blockage, then gain of an antenna will be reduced here. Now if you consider that a Cassegrain or a Grojarian antenna, in that case, that due to that reflector, there will be a blockage there. So that's why that blockage will be more in a Cassegrain antenna. Even if you consider that a prime focus antenna, blockage is more there, and because of that particular blockage, so efficiency is reduced. So that's why that gain is reduced. So to avoid that particular blockage, so then we can use a offset feed antenna, and that offset feed antenna that is to be placed not on the main axis. Okay, not generally we can say that this is about a parabolic reflector, and parabolic reflector, this one is about a main axis. That offset antenna is not to be placed on the main axis there. So that is the called as a offset antenna. So that offset antenna, it is nothing but a simple a reflector is there. This one is about a reflector, and for this reflector, this one is about your main axis. Okay, this is about, you're supposed to consider that this is about a parabolic reflector. Okay, parabolic now. So now this one. Now in that case, supposed to be this is about a main axis for this. Here we use a horn antenna. We use a horn antenna here. So means we say that if it is to be used as a transmitter here, so now a signal from this that will be transmitted in a space likewise. So this is about your, we can say that a offset feed horn antenna, and it has a single reflector. So it's again another way of designing that offset feed antenna. Here we have the parabola here. This one is about a main axis there. Okay, this one we say it is about a main axis now. And for this, we supposed to be consider that a sub reflector. We can say that here is our horn antenna. This one is about your horn antenna, and then we have the sub reflector. Signal coming from this horn antenna, it will be reached to the sub reflector, and then it will be reflected from the sub reflector, and it will be propagating likewise, or some of the signal that will be propagating likewise. So this one is about a, what we can say that a offset sub reflector antenna. So here, that on this particular main axis, that antenna is not present, your primary feed antenna. So now if you consider that this one is about a main beam axis, that horn antenna is present. But in offset feed antenna, that horn antenna is not present on this main axis of this antenna there. So that is about, we can say that a offset antenna or a offset feed antenna. Nowadays, if you see that at your home, that dish TVs are used. So old days people have used that main, that feeding or this feed antenna is used at the center there. But nowadays, if you see that, it is about a offset antenna there. And because of using this particular offset antenna, so blockage or whatever the blocks are there, that can be reduced there. So that's why we can use, we can increase the efficiency of the antenna, as well as we can increase the gain of an antenna there. Now similarly here we can say that reflectors are used. So if you consider that another case of an antenna, that is about a multi-beam antenna. So so that a multi-beam antenna, so there is in that case there are the various patches. If supposed to be it is a microstrip one, so there are some various patches. So this patch is to be providing the multiple beams. If you see the radiation pattern, so likewise, so there are the these are the regions to be covered by this particular multi-beam antenna. But again, we can design using the array or using the dipole again. So in that case, that region is defined by this particular antenna will be a different one. So we can say that this is about a beam provided by this antenna, or we have a mesh type structure. In that case, antennas are present, and then it will provide the multi-beam type of a structure there. Or we have the that is about a half cylindrical structure, and then in front of this axis of this, these are the multiple reflectors to be used, whether it can be a dipole, means at the center axis, means half of this portion. Okay, if you cut the pipe and at the center of that particular pipe, if you place that multiple antenna, so then beam coverage will be a different for this antenna likewise. So this is about a beam coverage. So it will provide a multi beam there. Okay, that is about a if you use a means this is about a center of your pipe. So likewise, so we can say that this is nothing but a center. So at the center that antenna is to be placed, then it will provide a multi beam antenna. So now use of this multiple beam antenna is just like average that area coverage that will be for the different region. So we can use this multi-beam antenna. If so, our aim or our need is supposed to be for the given different region. So in that case, this multiple beam antenna has to be used there. So means different various type of a feed antennas can be used, and because of that various feed, even if instead of a dipole, we can use the horn antenna also. And then this similar structure is used just like a single horn antenna. If it is a multiple horn antenna, so then multiple beam we are getting from this multiple beam antenna there, or a multi beam antenna. So there are the different feed. So each feed they are directed the signal toward the reflector, and reflect the signal. This each antenna is to be feed by the different particular signal, or we can say that or a same signal, but we get that a different coverage there. So if you see that the mobile towers and all, and for the given mobile tower, so there are the multiple antennas are present. So likewise, mast is there. In that case, that mast will cover this particular region or this particular area that will be covered by this antenna. Likewise, so there's about the single tower will cover the multiple area, and in that area, many users can be connected to this multiple beam antenna. So that how to design that reflector for this particular antenna, it is depending upon that what type of feed we are using. But if we consider that a horn antenna there, so then we need to find out that what will be the focal point or a focus point for the given reflector there. And then efficiency and gain will be improved if it is a horn antenna, and if it is a dipole, the efficiency is reduced. So that is about a various antennas. Now these antennas to be used in a satellite communication there, or we can say that to get that multiple beam output, so this type of antennas are used. So now next is about we will see that the antenna tracking. So that why this antenna tracking is necessary, because from the earth station we are transmitting one particular signal, to the satellite. When the signal is reached to the satellite, so then that level of the signal, whether it will be higher level or a lower level, so according to that, we can consider that a position of the satellite is a that particular place or not. If supposed to be that position is varying, so incoming signal received at the Earth station as well as transmitted signal from the Earth station to the satellite, so that level of the received signal will be reduced there. So that's why a sample pulse is to be sent from the Earth station to the satellite to verify that what will be the power received by this. So generally we can say that we have the antenna for this particular purpose. We will use the antenna. It has a high gain, as well as we can say that the beam width for this particular antenna is to be a small one. Now these are the necessary factors while considering the direction of that antenna, or these are the two factors that will minimize the pointing error. So we can use this type of an antenna which has a high gain and it has a small beamwidth. So generally, if you consider that a geostationary satellite that will transmit the signal, or geostationary satellite moving from that particular position, even if it is moved to that area coverage for this, that will be a plus or minus a 3 there, that window, or within that particular window, that geostationary satellite will move there. Now, in the case of that Earth station, if it is a smaller, then what happen? Then we need to track the satellite, and then once we are tracking the satellite, then we are able to receive the higher signal level, or we are able to transmit the signal there. Because we can say that a geostationary satellite, if you consider that distance will be large, high, range is large. So that's why for the small Earth station, that tracking is very important there. Now at a home, direct to home television, we are receiving the signal from the satellite. That satellite position is fixed. So that's why whichever the signal we are receiving at home through the satellite, so that have the high gain or received power is to be larger. If any disturbance occur, then that level of that received signal will be reduced because that distance is large. But if you consider that if instead of a geostationary satellite, so if you consider that the satellite is in low Earth orbit, so in that case, that satellite will be available for only a short duration of a time. But in the case of a geostationary satellite will be fixed at that particular position, but only due to the disturbance, a small variation will be occur. But in the case of a low orbit satellite, that satellite will be visible to the Earth station for a short duration because a low Earth orbit satellite, that one period is equal to the 90 minutes or to 100 minutes. So because of that one period of rotation of that particular satellite is about this 90 to 100 minutes. Then after 90 minutes, that satellite will come in the region of that Earth station there. So in that particular case, so that satellite, when it will transmit the signal, so Earth station is to acquire the signal, or that Earth station is to receive the signal within that particular period of a time. It's what will be the visible range of that particular satellite, because that satellite will come after every short duration there. So that's why if it is a small Earth station and your satellite is in a small orbit, then for the given visible range of a satellite, then we need a tracking there, tracking of the satellite. Because that low Earth orbit satellite, that satellite will be moved from the given particular period of a time, and that satellite is visible only for a short duration. So that's why for a short duration, if you wanted to receive the signal or transmit the signal, then in that case we need a tracking system, because we need to communicate only in a short duration there. But in the case of a large and medium earth station, that tracking system is necessary because they are communicating to the, or they have the multiple applications there. But if it is a small earth station, only for a specific period of a time it is to be used. But in the case of a large and medium earth station, they need again a tracking because of the same purpose, or we can say that because of that a short duration of a time there. So tracking system acquires the satellite, and it will continuously, and it will continuously track the satellite, and that communication will be possible through this. Now there are the various types of tracking system. So we can track the satellite either using a manually, or we can say that a program tracking there. Now if you simple see the block diagram of a tracking, why this tracking is necessary, because and how this tracking works. So in general, we need to consider that a antenna control system, in that antenna control system we can give the input that will be from the program track data, or we can say that a manual track data. As I told you earlier, we can say that a tracking, it can be we can say that a manual, or we can say that a program tracking. Another is about we can say that a automatic tracking, or we can say that a auto tracking. But in the case of an antenna control system, if you see that, so that we require a data from the satellite, so that data means what, a small thing, sample signal is to be sent, and then that sample signal is to be received from this satellite there. Just like we have seen that telemetry tracking system, in that telemetry tracking system we say that we need to send a one small pulse, and then whichever the signal we are receiving, so according to that we can, here is a small vertical motor or a horizontal motors are there, so that will rotate the satellite in the different position or a different direction there. Okay, likewise we can consider that we will measure the position of the whatever the antenna there, and then according to that servo amplifier will produce the input to the antenna drive system, and then it will change the position of that particular satellite. Now, if you consider the basic here, so it has some various motors. So we can track the satellite. We can track the satellite, and then according to that, Earth station is to be moved there. Means that basic Earth station or that Earth station antenna that we say earlier, it is to be steerable one. That antenna is to be steered in azimuth or elevation there. So we have the two scope here. We can rotate the antenna in azimuth, or we can say that a elevation. Okay, so now the position of the satellite. This is about elevation, that angle. So we have the azimuth likewise angle. So we can say that elevation and azimuth. So according that that particular motors are there, that motors are rotating, and they will fix that elevation or that azimuth of an antenna there. So now once the signal is received, or according to that level of a signal, then a control system will work for providing the input to this antenna, and then change the position of that azimuth and elevation. So it is continuously tracking the signal, and then once we are getting the higher signal level, then that antenna is to be fixed. Now there are, we say that a type of a tracking, that will be a manual tracking, program tracking, or we can say that a auto tracking there. But in the case of, if you see that a manual tracking, so in that case we require a operator. That operator controls the movement of that antenna to align the major axis toward the satellite there. Okay, and that antenna will fix, once that direction is fixed, then we will measure that, we need to measure that what will be the elevation and azimuth, and then that position is to be fixed there. So for that purpose, so to fix that azimuth and elevation, that data for the azimuth and elevation for the given antenna is to be given manually to the system there. Means values of that elevation and azimuth, that values is to be given to the antenna control system. So according to that, it will produce a output, and then antenna drive system will drive the whatever the motor there according to the input there. So means we can say that a antenna control system, that unit drives the motor through the servo amplifier, and then that antenna will move in the desired direction according to the value of input given, that is azimuth and elevation there. So actual position of that antenna is to be fixed because of that, whichever the signal we are receiving by this receiver. So the difference of that particular signal, if it is a zero there, then in that case we're supposed to consider that the position of that encoder is to be fixed at that particular point. That is about a manual tracking data. But in the case of a program tracking, so in a program tracking, just like we know that a satellite is to be disturbed, or position of the satellite is disturbed according to the disturbances in day or night just supposed to be considered. Means every day that position of that satellite is to be varying, supposed to be considered now. So according to that, we need to predict the path of the satellite. We need to predict the path. We're supposed to be disturbance occur every day for a degree of 1 degree, suppose consider now. So according to that, that path is to be predicted by the eh, satellite there, and according to that, that data is to be feed. So in this case, what happened? So means we need to fix or we need to program the data, and in that data we need to provide the position of the satellite, and then according to that position of the satellite, once the data is programmed, so then that antenna is to be directed towards this particular satellite direction there. If that is a data, it is to be programmed, or that is a data given for this tracking the antenna or antenna tracking system to the satellite there. Means track the satellite there. And that is about a program data that is to be feed here. One particular file is to be feed, and in which that position of that satellite is to be given in that program data. When that file is given the input to the antenna control system, then it will control the antenna and track the satellite there. And that file, program data, that file is to be updated every weekly basis or a monthly basis. And that accuracy of this particular program track data, that is depending upon that what input we are providing or what data we have generated for tracking the satellite there. So that is about a program. But manual tracking data, so operator has to provide the information, and according to that, we can vary the position of the satellite, that position of that antenna, and then we can track the satellite. So that a program tracking, it can be a open loop or a closed loop there. But in the another case, if you consider that a auto tracking, so that auto tracking is nothing but it to be a closed loop system, and in that auto tracking, one signal is to be transmitted by the satellite, and that signal is called as a beacon signal. Beacon signal that is to be transmitted to Earth station. So we will transmit that satellite. Okay, satellite send the beacon signal to the Earth station, and then Earth station receive that a beacon signal, and then according to that, whatever the parameters of that antenna is to be changed, or we can say that based on this beacon signal level, then we can find out that what will be the position of that antenna there. So means whether it is directed toward the satellite, or because generally we say that irradiation pattern of antenna is likewise. So this is about a half power point, 3 dB point suppose. So this is nothing but a beam width. And this particular direction is nothing but the bore site of an antenna. So in that case, at a center, at this particular center, it has a maximum value. Now then, based on that received beacon signal, we can find out that what is the actual bore site of an antenna. So means we can say that we'll have this beacon signal received by the Earth station and earlier signal we are receiving by the that from the satellite. So means two signal needs to be varying with that at what will be the maximum position. So means we can say that beacon signal received by the a two offset pattern, if it is equal, then we can say that both sides of that antenna will coincide toward the, or we can say that it is adjusted. Now here we are adjusting a satellite, not a satellite antenna. We are adjusting the Earth station antenna. So means satellite position is a fixed, supposed to be geostationary satellite. We supposed to consider. So then satellite position is fixed. So only we are changing the position of that Earth station satellite. Sorry, Earth station antenna. We are just changing the position of that Earth station antenna by receiving the signal from the satellite, and according to that beacon signal, then we can say that a both side of antenna is to be changed there. So here we are not adjusting that a satellite antenna, we are just adjusting the Earth station antenna. So satellite antenna is adjusted at the time of launching the satellite there. Once it is placed in the given orbit, then it will open up that antenna, solar panels and all. And according to that, the antenna of the satellite is to be adjusted. Once the satellite antenna is adjusted, then it is fixed. Only we have a scope to adjust the Earth station satellite. So now we can say that that particular beacon signal is to be sent, and then according to that, we can measure that level of the a signal there. If for the given radiation pattern, if the main axis has an angle, small variation, suppose we say that likewise we have the maximum here, likewise this one. So means this one you can say that there is a small angle between these two radiation pattern. So we need to find out first what will be the satellite direction, and then according to that we can track a satellite there. So there is a difference is supposed to be in the beacon signal or that particular main axis of this radiation pattern towards the satellite direction. Then we can say that whichever the pattern we are receiving, that two patterns they provide the unequal signals for the beacon there, and then it will indicate the difference between that particular, or you can say that there is just you can see that there is a difference in this radiation pattern of this two particular beam axis or that particular beam there. So if there is a small variation in that particular beam, so means we can say that there is a small error, and then we need to fix that antenna axis toward the satellite position or a satellite direction. So that's why we should know that what is the tracking axis of the satellite first. So there are the two types of a auto tracking method. One is about a sequential lobing, and another is about a simultaneous lobing. We can say that we have a two type, a sequential lobing and a simultaneous lobing. Now there are the two types of a lobing, and according to that, we can find out the tracking error by comparing the beacon signal received by these two antenna patterns. So now we can consider here first a sequential lobing. In the sequential lobing, the tracking error is obtained by comparing the beacon signal. Now then, in that sequential lobing, we need to receive the signal sequentially by these two antenna parameters or whichever the patterns we are received. Then according to that, we can obtain the error, and that error is called as a tracking error. So there are the various methods in the sequential lobing. So that methods are a beam switching. Then we can say that a conical scanning. Then we can say that step tracking. Then we can say that electron beam squinting, or we can say that smoothed step tracking. Now, in the case of a beam switching, so that whatever the earth station we say, now that for the given earth station, we should know that whatever the satellite direction. This one is about a satellite direction. And for this, we need to find out that a generally a antenna generates here a two patterns. We can say that this one is a pattern of an antenna. This one is about a pattern. We can say that beam A, we can say that a beam B here. And this one is about a satellite direction. Now, if you consider that this one is about a beam axis, this one is a beam axis for this beam B, and this one is about a beam axis for the beam A. So, in this tracking technique, that antenna generates a two pattern that will be symmetrically above and below the bore side. Now, this one is about a bore side. Bore side means what? This is the direction towards the satellite. This is nothing but a bore side. It's above this one and below this. Okay, means satellite, that antenna generates a two pattern. One is below and above them. So now if you see that here, at this particular point or a particular position there, now from this here, we have this a main satellite position. Now right now if you see that that main axis or a satellite axis we supposed to be considered here, they are matched right now. Okay, so this is about a satellite position, and we supposed to be draw a radiation pattern likewise, and then another is about we supposed to be consider that likewise. Okay, actually, same beam is not be there. This is about a satellite direction. So this one is about for the given antenna. So this one is about a main beam axis, and for this antenna, this one is about a main beam axis. Now, if you see that here, main beam axis coincides here, and another beam axis it will coincide here. Okay, these two position because this beam A and beam B here. So that is about they are coinciding at that particular point. We say supposed to be this is about V1 and this is about supposed to be we say it is the V2 now. When the both side is aligned to the satellite direction, in that case that received signal from each pattern that will be equal and that will be same means both side. Okay, if it is the same both side there. Okay, like that. So it will be matched there. If that both side has an angle with the satellite direction, now this is about a both side. Now this one is the angle here. So from this one is the angle. Then the received voltage by these two pattern are different. Now this is about the that's why it is about a different here. So now we need to find out a satellite direction, whether that satellite direction is above the bore side. In that case, the voltage V1 received by that pattern that will be larger than the voltage received V2 received by this pattern 2. You can say that V1 is greater than the V2. So in that case, that satellite is direction is above the bore side. Okay, now